Welcome to another video from Chapter 6, again with the normal approximation to the binomial, and this one's going to be the actual application, an actual problem. So for our example, we're dealing with delayed flights. It's approximately 18.28%. If they sample 150, what is the probability that fewer than 15 would be delayed? And notice this is single flights, a flight. Not an average. In other words, it is not the sampling distribution. So that's important to note as you're looking at these. You are approximating the binomial. And the binomial has those certain requirements. Identify in this case n is 15. Excuse me, n is 150. 150 flights. S, since the question is in terms of delayed, S would be delayed. Failure then, F would be not delayed. P is the probability of that success, which is 0.1828, and Q then being 1 minus P is 0.8172. And notice you don't need the function. You don't have to identify the probability function because you're going to be approximating it using the normal. What is required is that NP, which is 150 times 0.1828, 27.42, and NQ, which is 122.58, are both greater than or equal to 5, which means it's okay to use. And the mean, when we go to the X normal concept, the mean is already calculated NP, 27.42, and the standard deviation is square root of NPQ, which is 4.73. So we've set up the initial parts. As you're looking at it, this would be step 1 to begin with. Step 2 would be making sure it's okay to use. And then step 3 would be identifying the mean and standard deviation of that normal distribution. Then we have to go and answer that question. It wants to know in the binomial, what's the probability that there are less than 15 delayed flights? And again, that's in the binomial. The question has to be answered. Again, that's in the binomial where it's asked. It has to be answered in the normal because we're using its approximation, and they are not the same. That's where that correction for continuity is. So again, with the 15, the less than 15 is 14 and below, halfway between that, 14.5. So x being less than 14.5. That is changing it to z, because we have to go to the standard normal, x minus mu over sigma, 14.5 minus 27.42 over our standard deviation of 4.73. And make sure that you use your parentheses. Parentheses around that numerator. That gives us a value of a negative 2.73. So in the standard normal probability that z is less than negative 2.73, using our table, it's the same table we've used on the other normal problems, 0.0032. So that's doing that calculation. Looking at steps again, one was identifying the distribution for the binomial. 2 was checking that it was okay to use. 3 was identifying the parts of the normal. 4 is to write down that probability in the binomial. 5 is that correction for continuity, rewriting it in the normal distribution. You might need to show this sketch over here, but not required. Rewriting it is required. Then you have to do step 6, finding your z-score. Step 7, writing out the probability in the standard normal. And then step 8, actually calculating using the table. So 8 steps now. The 2 huge important ones that are new: correct for continuity and making sure it's okay to use. So that's calculating probability using the normal approximation to the binomial.